going to find, this is telescoping series. We're finding the sum of this telescoping series. So the first step to find the sum of this is to rewrite this as a partial fraction decomposition. So what, you guys want to do that for me? What would it be? A over K plus B over K minus 1?
Yeah.
Yep.
And A would be, so plug in 0. Basically, if I'm taking this, I'm finding out what makes this 0, which is 0. So cancel that out and plug 0 in here. So A equals 1 over -1, which is -1.
Mm-hmm.
Right,
Wait,
guys?
how'd you get that?
This is the way I do it. If you look at that, you say, what is this? How is this undefined? How is this one undefined if it's K equals 0? Then you take your original thing and you cancel out that piece of it and you plug in 0 for the other one.
She has us doing sorry, what's it called?
Systems.
Partial fraction decomposition, with systems and stuff.
Yeah, I think this is a shortcut. I saw this on a YouTube video. Seems to work pretty well. So I'll teach you the shortcut. So what makes this equal 0?
1.
1.
So take that thing, cancel out that term, because obviously if you put 1 in there, it wouldn't work. And now plug in 1 for the other case.
That would be
so B equals 1 over 1, which is just 1.
How'd you do that with A?
So again, plug in what makes this 0? It's 0.
Yeah.
Well,
So
how do you know that has to equal 0?
This is just like the hack.
How do you know that K beneath the A has to equal 0?
Well, how is this undefined? For what K value is that undefined?
0.
0.
Oh, yeah. Okay.
And for what K value is that undefined? 1.
1. Okay.
So to find A, you cancel out that part of that denominator and you just plug in 0
for the
to
remaining
the other
K.
one.
Oh, okay. I get it now.
That's the hack.
Then it's just -1 over 1. Okay.
Yeah.
I think that makes sense.
-1 and 1.
Yeah.
Okay. So this equals, I could rewrite this as the sum as when K goes from 2 to infinity of -1 over
K.
K plus 1 over K minus 1. Okay. Now we're going to try to find the telescoping. We're going to write out several terms of this, or this is kind of like your A sub n. This is like your A sub n term. And we're going to write as many of these as we can up until like the A sub nth term, essentially. So the first one we plug in is 2, because that's what it tells us to do. So the first term would be -1/2 plus 1 over 1. Because if I plug in 2 here, I get 1 over 1, right? That's the first term. Plus, because that's what summation is, plus the sum. Now I'm plugging in 3. So -1/3 plus 1 over 3 minus 1 is 2. Plus, keep doing that until we see a pattern. -1 over 4 plus 1 over 3 plus. So now I'm going to go back before I keep going, and I'm going to cancel out what I know cancels out. So that cancels with that. That cancels with that. You can see what's going to happen, right?
Yeah.
Vincent, can you see what's going to happen? So let's keep going.
The 1/4
Let's keep going
will
with
cancel
it.
out too.
Now I'm going to plug 5 in. So -1 over 5 plus 1 over 4. And you can see that it's always going to cancel. It's just going to keep canceling. So you're going to have 1. That's never going to cancel. Right? So this is going to equal 1. And then let's see what happens at the end. of it. So to find out what happens at the end of it, I'm going to put my last term, which is a sub n when I plug in n. So it's going to be negative 1 over n plus 1 over n minus 1. That was the very last term. That was the nth term, right? Did
Yeah.
I do it right? And then the n minus first term, is negative 1 over n minus 1 plus 1 over n minus 2. Do you see it?
Yeah.
And the one before that was negative 1 over n minus 2 plus 1 over n minus 3. So you can see what cancels here too. That would have canceled with that. That would have canceled with that, and so on all the way back. So the only thing left is negative 1 over n.
Yeah.
So these two things are left. So 1 and negative 1 over n are left over.
Yeah.
So that's my S sub n, my nth partial sum. And the the theorem that we've learned is that the
Hang on.
infinite sum of a telescoping series is always equal to the limit as n goes to infinity of the n of the partial sums.
I thought we were using K for the value in the subscript, so like S sub K.
We were using k, but remember I plugged in. This is my nth term now, so I plugged in n for the k. It doesn't really matter what you use. It doesn't really matter. But I think the proper thing would in this case would be that. So what's the limit as n goes to infinity of this?
Go away, Uncle.
That goes to 0, right? And it's just 1.
Okay. I got that. Yeah.
Is that the right answer?
Yeah. That's what the answer key says.
That actually wasn't as hard as I thought it was. Do you want to do the other one now too?
The answer key says instead of 1 minus 1 over n, it's 1 minus 1 over n plus 1.
Did I have the partial sum wrong? Did we do something wrong with the partial sum?
It said S of n equals 1 minus 1 over n plus 1.
I know, but originally, did we do something wrong up here?
No, it doesn't look like it. It all looks the same.
Because I don't know how that would have been. I don't know where the n plus 1 would have come from. We never had an. We never had a. You know what I'm saying?
Yeah. Uh,
I don't. Yeah, I don't know where that would have come from. Do you have the work on that or no?
yeah, but I don't see anything different from what you did.
What did they do at the end here? How did they
When they
get
were
an
fine,
n?
what were you saying?
You said there was an n plus 1 somewhere in there?
Yeah, that's like when it's in the limit when n approaches infinity, and then in the parentheses it's 1 minus 1 over n plus 1 equals 1.
But you don't see this work right here where they wrote out the telescoping series.
They wrote it out just a little different. Oh wait, they I don't think this matters, but instead of putting the 1 over k first, they put the 1 over k minus 1 when they were finding the s of 1, s of 2, s of 3.
It doesn't really matter, but I don't know how they came up with the k plus 1 or the n plus 1 in there because they're always plugging in. I just don't understand where they came up with that. I don't know where they came up with the.
Can
You know
I
what I mean?
take a picture of the paper real quick? I just have a question, like relating to the way that they wrote it.
Yeah, you want to upload it here? Sure. Yeah.
Um, So this is just for problem 4. Just I understand the answer. I just have like a quick question as to like why they wrote it this way.
Is this a
It's
different
tiny.
number
It's there
four?
though. No, the same number 4.
This is the one that we were
It
just doing.
deleted
Was this
itself
number
because it said
four?
that it just deleted itself because it says that I don't have permission though.
Oh no.
Well, the problem is that the question says on top it's infinity. The bottom says n equals 3, and then like the side says 2 over k squared minus 2k. So does it want it in terms of n or in terms of k? Because everything else only has it in terms of k, but for some reason that one has it in both n and k.
Um,
So like I'll just write it out.
I don't. Yeah, I don't really know. I don't know really know what to say about that because I saw a typo. I thought it might have been a typo.
It may just be a mistake or something because everything else just uses k, but this one uses n and k. So
Yeah,
I'm not
no,
really.
maybe he has it already on here. Look up at the top. Is it number four? Yeah, it's number four. Do you see it? It's this one you're
Yeah,
talking
it's
about.
got both n's and
Yeah,
k's, even though
we were
the other
talking
one
about that.
has.
We were talking about that. We didn't understand why they did that.
I think it may just be a mistake, and they were trying to use just k. I don't
I
know.
think it might be. I think it might be a typo. Yeah.
What I thought too.
So that was throwing me off. I wasn't sure why we were just switching back and forth between n's and
Yeah,
k's.
I think that's a typo maybe. Yeah. So I don't know why, Rayhan. I don't know if there was a typo or if we made a mistake somewhere, but it kind of seems to me like I don't know how they could have gotten unless they were making this the a a sub n plus one.
Yeah,
Maybe that's what they were doing. Maybe they were going further. That
that's
could have been
teacher.
that could have been what they were doing. They may have just been going further
Yeah,
instead of I see how I ended at a. Maybe what they're doing is going from a sub n to a sub n plus one instead.
yeah, that's what I think. But I could ask my teacher tomorrow.
It doesn't really matter how you do it. I go backward, but you can keep going forward because remember it doesn't matter where your last term is.
Yeah.
It doesn't matter what you call your last term if it's a sub n or a sub n plus one or a sub n plus two. Doesn't really matter, and you're going to get the same answer.
Uh-huh.
All right. Do we want to do one more?
I've finished all the problems on
You're
this
good.